So I've made up this little board, 18 volt power supply, well, two 9-volt batteries, an on-off dip jumper, and a 8-pin dual inline socket, 10K pot. I'm going to have to do some explaining before we get to see this thing work. So there is a method to this madness concerning voltage references or voltage standards, whatever. This is the Analog Devices 586. It's right out of the data sheet. They have an option, actually two options. Normally this thing has a pretty good output. Very stable, very close to 5 or 10 volts. But if you want to make it better, then you trim it. And if you want to reduce some internal noise, you install a capacitor. Now here we have, say this is the 586, which is a 5-volt device. So the output is taken between ground and the output, pin 6. Analog Devices says take a 10K pot, preferably a 10 or 20 turn 10K pot, and connect it from the output to ground, and then connect the wiper to the trim. So that makes sense. We're feeding the output voltage back, some of it back to the trim, and we just have a voltage divider here. Here's the output voltage divider used in the Geller device. And what he does is use maybe as low as a 200 ohm resistor and makes the 10K more or less up with two fixed resistors and a potentiometer. If he used a 200 ohm 10 turn pot, then each rotation of the pot would move this pointer, the wiper, by 20 ohms. As opposed to this, where each rotation of the adjustment knob moves us 1,000 ohms. This paragraph was written by Joe Geller. I bolded and underlined this portion of it. Joe states, when we use a 200 ohm trim pot, the two R's, that's the fixed resistor above and below the trim pot, are selected and tested for each chip, because the trim range, he's referring to this trim range, is very small compared to the full range with the Analog Devices 10K trimmer. He's testing each chip or each batch of chips to determine the values of the two R's, these two resistors. I would think he does that by installing the chip in a circuit like this, burning it in for 4 days, trimming it. I may trim it first and then burn it in. When it's done with the burn-in, retrim it to an output of 5 volts. And then measure the resistance from here to here and from here to here. He probably unplugs the chip or has some sort of quick change chip holding system. This paragraph is I've read all of Geller's stuff on the web. He does make mention of a manual, but I don't know where that is. So when we use the 200 ohm trim pot, the two resistors are selected for each chip. For DIY builders, which would be me, we recommend a 1K ohm trimmer, and as a first approximation, these two values. So I ordered the same resistor in these two values. Now I ordered them from eBay, for example, a 7.32, a standard 8 watt resistor. I did get them from a US distributor, but look at the difference in size between these resistors and these. I don't believe that these resistors from eBay meet the RC55LF, which is a mil-spec, I believe. These are just resistors. These, however, have extremely high water resistance. They're extremely stable with age, and more importantly, they have a very low temperature coefficient. I'm going to build a standard using both, two standards, and see how they work over a range of temperatures. Analog Devices would have you use a 10K pot. Joe Geller would have us use something like this with a 1K pot. Now he also, Geller, provides a jumper so that this whole, the string, the current flowing through it doesn't change. But we can remove a jumper and let the trimmer float. So with the jumper out, we just are getting the native or best quality from the factory voltage, output voltage. Another chip is this REF 5050K. The Texas Instrument data sheet for the REF 5050K shows a 10K pot, 1K in series with it at the bottom. I own this I own both of these, the DMM check and the VREF-01. Instead of a 10K pot, it's a 500 ohm pot. I'm not sure why this is 488K versus 470. Maybe he just had them. And maybe I measured it or read the color bands wrong. So you can see the designer of these two devices. I think they were the same guy, looking at the style of construction and the components used to build it. Did the same thing as Joe Geller. He reduced the pot and made up for the reduction by placing fixed resistors both above and below it. So the reason for using the fixed resistors is to make the adjustment finer, so we can more accurately hit the desired output voltage. This is a package. It's from Premier Choice Components, New Jersey. Well, this is interesting. Certificate of Compliance. I ordered, I guess, some AD 586MN. And this is, it does have a seal. I guess it's a notary seal. You can read that. It says analog devices AD586MN. I'm going to be using these shortly, so I don't mind opening the package. Well, they appear to be analog devices. Well, the date code is 3 of 05. Fast and free domestic shipping. Well, there they are. Charged me $23 and $5 shipping. And there are Premier Choice components on the eBay. The AD586 is a 5 volt plus or minus 2 millivolt trimmable reference. So now we'll wrap around to the very beginning of the video. Here's the board. I'm going to put an AD586MN in. I'll turn the potentiometer to one end. And you can see that it's 5.5034 volts. I turned the whole way up. That's more than half a volt above the 5 volts we desire. So we'll turn it down the whole way. And we can take it down to 4.1826. So that's a pretty wide variation if we're trying to hit precisely 5 volts. So let's see whether we can. Now, I overshot it slightly. Now the chip but without the trim would be better than this. Can't quite. There we go. Just removing the adjusting tool. So I'll remove the power from the unit. And I'll remove the chip from the socket. I'll measure the upper and lower resistance values above and below the trimmer. That's 2.774 K, and below it is 3.4838. And so if I take the 1K Geller recommended pot and I put half of it below and half of it above, I've adjusted it halfway. I get 28% above the trimmer and 63% below the trimmer. What I measured just now is 30% above and 70 below. Now I understand these don't total up right. I think I've had a rounding error when I rounded them off. So the question is, if I take this 1K pot and move it down to increase this percentage and decrease this, can I move it 2 or 3% of the total? Well, yeah, that's 1K. 500 ohms is much more than 2% of this or this. The next thing I'm going to do is build a board like the Geller SVR.